Hello? Okay, here we are again. Now we have Žarko from Endava talking about VR, which is actually a topic for our conference this year. And of course, you're free to ask questions during the talk using our chatbot. We are going to answer it after the talk, and just enjoy this awesome talk. Thank you.
Thank you. Okay, hi guys. Just to check if... Okay, so here we go. As already introduced, my name is Žarko Milenković. I work for Endava company. Primarily, I'm a software developer that primarily works on the server side and on the application services level. Although I like to brand myself as I'm an early adopter of pretty much any new technology out there. Tonight I'm going to talk with you about a short research that we did inside of our company earlier this year. And it has to do with how we think we can use VR to improve conferencing solutions and systems. Before we start, in Endava we have a lot of experience of working on conference systems, developing them and maintaining them. Also, we have a lot of remote teams, so we have a strong culture, meeting culture in Endava, and even before VR, we constantly think of ways how we can improve them, how we can make them more productive and make them more fun. VR really hits that spot, and we wanted to try something new here. Before we started our research, we just put up some goals that we wanted to achieve. So we wanted to identify two solutions, how we can improve conferencing by using a VR. Then we, for each of those approaches, we wanted to develop a small proof of concept in order to understand, is it really working, or what is it missing in order to work. Research time frame was 1 month for both proof of concepts. So this was a two-part problem for us. First, we wanted to identify really the way, and we wanted to understand what is missing from the software side to give ability to people to do these kind of things. We weren't focusing that much on the hardware. We used what we had readily available. Before we go into the research and our results, I just want to briefly mention and talk about VR and what VR is. Usually people think that this is something really new, and it is not. The idea of VR dates from the 1950s, and to me this is just one of the perfect example how human imagination really goes, you know, and how technology needs time in order to caught up with that imagination. This is the most basic definition for VR, and it is near eyes display that projects realistic images that then simulate a physical presence in some imaginary world. So basically your eyes are enclosed and your field of view is blocked, and then your eyes are tricked. They're receiving the images, each eye image from a display, and the brain thinks you are in some other place. I personally think that the VR is a new medium, the first new medium, you know, that changes the way we interact and present things in last 10 or 20 years, and it's all about experiences that you can create with VR. Now, having a VR, we can do some things that we could not do before, and we can present things in a way that were just not possible before having them. Especially because VR is starting to get more and more available to the mainstream and to any consumers. I will now show a couple of examples what those experiences are, and something that motivated me to really get involved into the VR and AR. So, just briefly wanted to mention, I don't know if you heard of any of these examples before, but scientists, neuroscientists use VR in order to create out-of-body experience. So the experiment setup is really pretty basic. Participant wears a virtual headset and it is recorded from with the camera. That image of him is played on the virtual headset in front of him, and then using some physical stimulants, usually a stick or a brush, it is gently stroked on the back. This creates a sensation for our mind to project us in the image that we see. What happens then is that, it is also important to mention that the physical stick, the motion is captured, and it is represented as physical, as a virtual one in the virtual headset. As soon as those two, virtual and the physical one, go out of sync, or we start feeling the sensation and we see the stick is still moving into VR world, we get the notion of being pulled out, or just our mind is confused what it is seeing. So that is something that was not possible before we had VR. The another example is robot-assisted surgery. You probably heard how remote surgery was done by using an Oculus Rift and robotic hands on the remote side. So this is a new branch, robotic surgery developed as a platform. It is a new branch of medicine that is really picking on, and it makes sense because you have expert surgeon maybe on one location, and it is just physically impossible for him to travel and operate on a patient on some remote location. By using a VR, motion controllers, and robotic hands, that are actually proving to be more stable and precise than the surgeon hands, he can do that surgery without traveling. So, and the next, actually, this project, In the Eyes of the Animal, I don't know if, did any of you guys heard about this project? Yeah, this is the project that actually got me interested, and it predates I think the first Oculus Kickstarter campaign, and this is what really got me interested in VR, and I wanted to develop the content for it. So what is it about? This is an human eye can see only 3 wavelengths of a color: red, blue, and green. And the animals can see much more than that. For example, the dragonfly can see 12 of them. And by using the VR, artists gave interpretation of how it might look to looking the night forest through the eyes of the animals. It is really, really magical. They had these special helmets made that incorporated the Oculus inside with a spatial audio. And actually, if you go to their site, you can check it out by using Gear VR or Google Cardboard Box or any web VR capable device. So these were really the examples that show how things can be done differently, and how they can allow us to do something that we could not before. VR is quickly being adopted. The first industry that adopted it was the gaming industry, of course, but now more and more military is using it, healthcare is using it, retail, commerce, they're all using it. You heard of the IKEA using VR and AR in order for you to try their products and see how your home looks before you actually go in and buy their furniture. So now back to our research and identifying 2 ways to improve conferencing. So after a brainstorming of a couple of days, we settled up on 2 ideas that we voted were the best for us and something that we were passionate on working on. So the first one is virtual conference meeting room. We call that massively multiplayer online conferencing game. Here it is just it is simulation of the conference room with simulation of collaboration tools in it. So you would connect just like in any other game and talk with your participants in that room. The other one is something that we were really excited about, and it is remote mechanical body controlled with VR. We call that the avatar body. Idea here is that you have a robot body on the remote side, and you possess it, connect to it, and by using the VR and motion controllers, you connect to it and interact with the people on a remote location, just like you would if they were there around you. So now we are going to go into a bit more details about the first approach. Here we also we built some goals that we wanted to achieve, especially because 1 month period is not that long, and we wanted to be sure to get our proof of concept that we were aiming. So our goals were to have a simple conference environment, to have ability to at least 2 participants to join and talk to each other. We need to create 1 simulation of 1 collaboration tool, and we wanted to have spatial audio. We thought that that is really something that will help to create a more immersive experience. For this kind of things, we really did not need that much. We just needed 1 general purpose game engine. Again, because of the time period, we wanted to use something that is readily available and that we can just pick up and use. 1 VR-ready machine and a VR headset with room scale support. We wanted to use motion controllers, so we really wanted to use either HTC Vive or Oculus Rift with full motion controller support. We did not consider the Gear VR or Google Cardboard Box or Daydream devices for this. Here you can actually see the screenshots from our proof of concept. Is pretty much basic, and if any of you did some work in Unreal, they can see that this is like basic setup of the introduction level. From the moment we start working on this solution, we saw that the VR is really natural fit for this, because in its definition it says it is created for simulation of a physical world, and that is exactly what we needed to do. The whole workflow and the process was exactly as developing a game and as playing a game. So for the collaboration tool, we made a whiteboard that any user could pick up the marker and start writing something on it. And for spatial audio, we used Steam Audio that really gives this support out of the box. And really, it was almost amazing how easy you can create this. in a matter, I think 1 week was enough for us to have a working example where we can talk to each other and write on the board. So from the software side, we did not see that there were any shortcomings here or that anything is really missing. It is all about simulation and enhancement of real-life collaboration tools. And this is really interesting because it is not simulation. It can really be much more because all the collaborative tools they are bound by their physical, laws, and you cannot do more with them. But by having a VR, things got really interesting, and you could do all kind of crazy things. For example, if you need to present some 3D model or discuss upon it, right now how it works, we share a screen, and the person on the remote side controls that object, rotates it around. There is a lot of talk, turning to the left, not that left, the other left, and stuff like that. And here, you just import that model. Everyone can, no matter how much of participants are there, 1 or 300, they can come as close as they want. They can write in space, they can write in 3D, they can examine it to extent that they would want. There is really no limitation. If you want to present something, for example, we would not be limited by this screen here. It could be huge and enormous. We could project over the sky sphere in a virtual world where we were sitting, and the experience would be just amazing. In order to show just how precise and good motion controllers are, here are 2 examples to the right. One is the Google Tilt Brush. So it is a tool that you can draw in 3D. So it is really amazing. It is a whole new movement of art that people are creating with it. And below, it is a graffiti from King Spray Graffiti Simulator. This is all in virtual reality, and the quality of graffiti is just as good as you would have it on your in the street or on the wall somewhere else. Precision is amazing, and it is truly funny how quickly our mind got strict. And for us, when we tested the hour, even simple simulation for 20 minutes or so, and as we started to get tired, from time to time people just wanted to lean on the table or sit on the chair, and they will forget that it is even it does not look that realistic, you think that it is physically there. So and this can be further improved and enriched by, having a proper designers, and you can have your own spaces. So your meeting room can be your personal space that you would like to show to the people. It can be the, a peaceful beach or Zen garden, or it can be the cockpit of Millennium Falcon or something. Whatever you imagine, you can create it, and just to show people really your world. And also there is this psychological thing there. I read that when people think that they are not being watched, and you have a conference and you're being filmed, and you think that people are looking at you and assessing you, in VR you don't have that notion. So you tend to be more relaxed, more calm, and participate more easily. In the end, our conclusions were that for this approach, nothing is really missing there. We had all the tools that we needed. Game development is very mature ecosystem. It is just crazy how much of time was spent into optimizing all of the game development tools, and I can say it from my experience that not nearly 30% of that time was spent on the office productivity suite or some other tools that we think are enterprise and that people are taking care of. It is an ecosystem that really gives you pretty much anything that you need. Any modern general purpose game engine would be a good starting point for this. Of course, one can go and create their own engine just for conferencing and optimize it. General purpose engines tend to come in bulk and with a lot of bloatware that you really don't use. But in reality, this is something that will help you jumpstart your project here. One thing that we identified and tried to dabble with a little bit with is the extensions for collaboration tools, for editing documents, for presenting, for example, PowerPoint, giving presentation in VR, and messaging and other tools. So this is the area where the most of the work would go. Now let's go to the second solution. This is the more interesting and exciting one. I already said, idea here was to have a mechanical body on remote side that you could connect and control it. Unfortunately, from the start, we knew that we could not create the complete mechanical body, and we wanted to understand the problem. So we settled for having a remote controlled camera that is tracked by head movements of the VR headset. Idea is that this would give us good understanding of the difficulty and all of the things that we need to do and develop to go for a complete system. So here, just as in a previous example, we set up some goals of what we would try to achieve. So we wanted to have a head-tracked camera control. We needed to have continuous stereo video stream. To mention here, so we decided to go with the stereo vision, and while in theory any two cameras can be used for to create a stereo stream, it is extremely difficult to synchronize those streams. So in VR, it is very important to left and right images that you are receiving to be synchronized. So most of the camera does not provide ability for you to externally control the shutter, and we decided to go for a camera that had that kind of controller built in, and that all the cameras are in hardware sync with the same clock. So we wanted to have real-time audio and video and control. This is also something that is very important, especially if you imagine controlling a remote system. Your controls needs to be instantaneous. So you need to, as soon as you move, the unit needs to move on the remote side. We wanted to have full HD resolution per eye at 30 frames per second. And camera movement needed to match a normal head movement. So as I said, it is very important that not to experience that you move your head and you wait slowly for a system to go to the position of your head. For the building blocks here, we used something that we had readily available. Here, any VR headset would do. We did not need motion controllers. We just needed something that can track the movement of our head. We have a stereo video camera, one combo of pan and tilt servos. That was enough for us. We did not want to have a roll because it would complicate the setup substantially. and we wanted it to be powered by some silicon on the chip, some small computer that we could fit in a package of our choosing. In the end, we ended up using the NVIDIA Jetson TX2 because we also wanted to do some basic computer vision processing on it. So here, actually, upper right, you can see our test system. So those are our cameras on the server controls. For us, the hardest choice was how to implement the real-time protocols. So what codec to use and what to choose there. We did not spend too much time breaking our brains around it. We choose the WebRTC because this is something that WebRTC is really made for. It is made for real-time communication. Although it is licensed, it is royalty-free. And the code is available, so you can hack it and add whatever kind of support you need for it. And it is a peer-to-peer communication. In pretty, there are corner cases where WebRTC would not be peer-to-peer, but in most usual cases it is a peer-to-peer communication, and for us that really means that we are going to have as fast response as possible. Latency wasn't a big issue. So whenever we are talking about VR, we need to talk about the latency, because as soon as our brain detects that the motion detected by our inner ear is different than the motion that we detect through our eyes, then the motion sickness kick in, and things do not look, nice. That's why when you have a low frame rate and you move your head but nothing is happening in front of your eyes, you instantly feel dizzy and sick. So we need to make sure that there is no discrepancy between, for the video that we are getting. This is much more trickier than the first solution, because in first solution you render all on your machine. The only things that you send over the network are positions of your participants and audio. So that is something that is really dealt with in the years, and it is really optimized. Here we needed to transport video, very high definition video, and to do that with minimum latency. So even if we could capture the images from the cameras in 0 time, encode it and decode it in 0 time, we are still dealing with a network that that has latency. So every network has latency, and it really depends on the state of that network that we what kind of latency we are going to get. Would it be 100 milliseconds, or a second, or even more than that? The biggest problem for us was definitely a codec. So we use VP9. It was hardware accelerated, and we also tried the H.265, which was also hardware accelerated, but they do their job very, very well, but they are optimized for having a single picture and compressing and crunching those pixels in a way to minimize the bandwidth that they are going to use by maintaining the resolution. Here we had a side-by-side images, and the overlap between them was very, very large, but the codec did not detect that properly and good. So we ended up using much more bandwidth that you would use with the full HD stream. We did tackle a bit WebRTC, and we did try to hack it. Use the override the CPU overuse algorithm that is inside. This is also something that is that is specific for WebRTC, you really cannot control the image you are getting. So you are going to request a full HD stream, but the algorithm beneath is going to decide for you, based on the bandwidth usage, based on the CPU usage, based on the state of your machine, what quality of the video it is going to provide for you. Since we were limited by the time frame that we had, we could not spend much more time taking a look into that, but that is definitely one area that it can be improved. Here are a couple of screenshots from, for this we use WebVR. So for the virtual conference, we use the Oculus Rift with Unreal, and here we use the WebVR because WebRTC is kind of connected to the browsers and everything, and we wanted to go happy and shortest path. We used Electron, and WebVR provided to us everything that we need. It is just using an A-frame and rendering the video on the WebGL canvas. In the end, we did not manage to get the desired full HD per eye. We ended up with HD resolution per eye, and it averaged around 500 milliseconds latency. So based on the subjective feedback that we got from the participants, this was really a threshold. So if the latency went above the 500 milliseconds, then the people would not like this, and they got a bit of a motion sickness. But then again, this is just optimization that definitely can be tackled and can be brought up to even to 50 milliseconds. So it is just one area that needs to be specifically, worked on. Another thing identified was that there was really no codec that we could use for this kind of thing. Although there are some documents that define codecs that are going to explain how the stereo video should be encoded and decoded. There are only some proprietary codecs available there that you can use, so there was not one free that we could use. That is also one point where communities should get involved, although both Facebook and Google are working on their cameras. Facebook has their 360 cameras, and I think they even are providing codec that they use for that kind of video, so anyone can use it. Google is going to do the same for their 180 degrees camera. Another thing that we saw that would be a great thing to add from the previous solution, spatial audio was something that was really good, and it gave you that immersive experience. Having a spatial audio here will also help. This would mean that the robot body needs to have also the special microphones that are going to pick up direction from the sound. Some of the problems could be mitigated. We did debate about this by using different kind of cameras. So if you have 180-degree camera or 360, then you would not have the problem of dealing with the latency, because the picture will be always there, and your head movement will instantly look at just the another corner of the video. That video could have latency in it, and you maybe would not see the things in real life, but you would not get motion sickness. So that is also something that could be used to go around this problem, but then these kind of cameras increase the resolution, and then you would need to optimize your codec in order to limit the bandwidth usage. And of course, another step for improving all of this would be improving of infrastructure. So 5G, for example, is in the works for a couple of years now, and they're promising insane things like they are promising 4 milliseconds latency. So that is almost instantaneous. So this is example how of just using another infrastructure we could fix some problems that we were having. And this would be a wrap up and conclusions that we got. So in terms of virtual conferencing, this is not a question. This is really one way where conferencing solutions are evolving. There are now, at the time of our research, there wasn't a company that provided this. There was an Alta Space, I think. They even have a Slack integration. They started 2015. They are really pushing that hard. But they were, I think, the only one. Now there are a dozen of companies that provide these kind of solutions. So this is really something where this branch is going to. Collaborating in VR is very fun, and it even improves some of the collaboration that you can have, especially for remote teams. But not even for the team that are located in one space in one location, they can. Through some games or through enhanced collaboration tools, they can really benefit from this. We did not find any software limitations for when we developed this. The only thing that is still holding this for not going to masses and not becoming a mainstream thing is hardware. VR devices are still bulky, they are still expensive, and they are not comfortable to wear. Not to mention that you need very, very powerful machine to really have the nice experience. I think this is okay because the VR is still in its infancy, and it needs to stay there a bit until the proper content is developed, because if it goes to mainstream too early, it can really collapse under its weight. There is already, I think, too much of expectations from VR and what it can do. I think that at the keynote that Unity gave this year, they identified something called gap of disappointment, where year after year, in 2015, 2016, they were everybody's projecting a huge amount of success and money from VR, and year after year VR did not manage to deliver that. It is going to take some time until we have the content that we would like to have here. So my opinion is that we are 5 to 10 years from the mainstream, and where most of us would use this VR system for collaboration and talking with remote teams. It is a good thing that VR hardware manufacturers are now preparing their second generations. They are cutting the cords, so everything is going to be wireless. It is going to be much less bulky, but they're still not at the point where everybody will want to use them. Avatar conferencing, that is something completely different. Working on this gave us a glimpse of the very exciting future that is not that near, like the VR conferencing. And not that too many things is missing here. It is just too expensive to be, that you could justified for someone to buy. So creating a robot body that can react instantly to your motions, and you control it with a VR, that is something that can work as a prototype, but not something that you could that easily sell. The only thing that we think needs to be worked on is developing of the highly optimized codec for stereo vision. That's also not that big of a problem. And until we wait our robotized bodies, we identified a couple of pivots that could happen to bridge that period. One would be to have a stationary conferencing system with 180 and 360 degrees cameras. For example, that kind of stationary system could be positioned here in the front row, and hundreds and hundreds of people from all around the world could connect to that and look around and hear this talk and conference just as they were here. This is also the main idea of Facebook's idea with their 360 camera and Facebook venues. Another interesting pivot would be to have a system that instead of robot body, they just use the drones that you control and fly around and talk with people. So drones are already doing this. They have their autonomy, and a bunch of people are using them for first-person view flying by using DVR. It is just that now they use radio frequency control, which provides them a very small latency, but there needs to be a bit work on that to have this small latency over the network. Okay, so that would wrap up my talk. I hope that you enjoyed it, and I'm now available for any questions that you have.
Thank you. Thank you. Okay. Do we have any question from the audience? Yeah.
Oh, sorry, I just need to press this, yeah?
Yes. Yeah. No, again.
Oh. Okay.
Okay.
Hi.
Cool. Hi, I'm Igor. I also develop VR stuff, let's say. I will ask you about the first method, because I found the idea of a boss on wheels unnerving. So, yeah. The first idea, I think, is great, and it will provide some new perspective to meeting. But I would like to ask you your opinion about, let's say, two challenges, I think. First one is editing a document. It's hard, I think, because it's very uneasy to work with the keyboard and the mouse while wearing VR.
Yeah.
And the other thing that I wanted to ask is your opinion. Is it better to have a generic avatar, like in Altspace, or let's say 3D model yourself and have that kind of avatar? So that's
okay. Okay, this is weird. I think I hear myself. Okay, so for the first question, yeah, it is hard to edit, but that's, for example, lip motion is a fantastic example of what you could use to really use your hands in a way you would. So lip motion combined with the keyboard, virtual keyboard, will give you ability to edit and present everything. So yeah, that is one area where additional devices need to be developed. Also, the hardware manufacturer for VR devices are developing special sensors that they want to detect our eyebrow movements, our forehead. They want to put a bit of make transition of our facial expression to the virtual avatars that we are having. Regarding the second question, it all depends. I think it is good to have some crossover, like a caricature of yourself in a VR, because this gives people a freedom to express themselves and make things, a bit more casual. But that's my take on it.
Thanks. More questions? Maybe next year we are going to have a virtual reality
conference. Yeah,
exactly. Yes. Who knows? Okay, that's it then. Thank you very much.
Okay, thank you guys for coming.